Welcome to Extra Maths. My name's Lee and today we're going to have a look at our grade 11 finance. Remind ourselves of some of our formulas and start thinking about the way forward to the matric syllabus this year. Right, so if we start by looking first of all at our formula sheet, we would see that we are given two formulas, this one and this one. There are others, there are in total 6 formulas for finance, but we're going to start with these two. Before we start, let's quickly recap what everything stands for. First of all, we've got P, which is actually the principal, which if you want to think in simple terms, is your original amount or your original investment. Then we have A, which stands for the accumulated amount, which is actually your end amount. And then we have N, which stands for the number of calculations. Sometimes we can think of it as the number of years, but the number of calculations is perhaps an easier way to think of it. And I, which stands for the interest rate. Now, in grade 11, we learned that the interest rate doesn't always have to be a yearly interest rate. It can be calculated at various intervals. However, this formula I've just gone through with you is the simple interest formula. Now, we're going to spend some time talking about the difference between simple interest and compound interest. In the second formula, the variables still mean the same thing, but now we're dealing with compounded. Now, you ask yourself, what is the difference? Well, in actual fact, compound interest is always to your advantage and also to your disadvantage should you be working with a credit card or somewhere where you've borrowed money. But if you are saving money, compound interest is always the better option. Let's go and play with a little easy question just to show you the difference. Let's take an amount of 1,000 Rand. And let's suppose we're going to work on simple interest and we're going to leave this thing to work for 2 years. So in the first year, according to my formula, the accumulated amount would be the 1,000 Rand, 1 plus the interest rate, which let's make it 10% for ease of calculation. It'll be 1 plus 1, because it's 1 year, times 10%. Now 10% we write as 0,01. Good news for you, you have got a calculator that allows you to work with percentages. So if you are more comfortable working with percentages, that is absolutely fine, because you can actually input that straight into your calculator. So over here, I'm going to go 0,01. We know that we get that because 10% means 10 out of 100. And thus that decimal 0,01. Right, so if we do that, we're going to get 1,000, sorry, 1 plus 0,01, which is 1,000 times 1,01. Now, using our calculator and inputting that, we can say 1,000, open the brackets, 1.01, close the brackets, equals. And we find that after 1 year, we've accumulated 1,010 Rand. All right, now if we go the compound interest route, and I think I'm going to put that one in blue so we've got an easy comparison, we would say the accumulated equals 1,000 Rand, 1 plus I, which is 0,01. By the way, what I'm doing here is I'm working with compound interest yearly instead of compound interest over certain intervals. We'll talk about that shortly, but let's first play with this a bit. Right, so that would be to the power 1. Now, if we pull up our calculator and we input this, so let's clear it. It's 1,000, open the brackets, 1 plus 0.01, close the brackets, raised to the power 1, which we don't even have to really do, but let's be good. And oh dear, we see that we get exactly the same amount. All right, so you might say to me, well, what is the difference? Let's talk about it. Let's see what happens now after 2 years. So after 2 years, let's have a look, and we see now with a simple interest, we've got 1,000, 1 plus 2 times 0,01. And let's pull up our calculator. Let's clear it. It's 1,000, open the brackets, 1 plus 2 times 0.01, close the brackets, equals. And we see that we've got 1,020. All right, well, let's see if things change now when we look at the compound interest. Using my blue pen again, we're going to now say the accumulated would be 1,000, 1 plus 0,01, but this time we're raising it to the power 2. So let's pull our calculator up again. All right, clear it. We've got 1,000, and it's 1 plus 0.01. Close the brackets, raised to the power 2. Okay, now that doesn't look too good, so let's go S to D to get it as a decimal. And we now see that we've got 1,020 and 10 cents. Remember that when we do finance, no matter what, we always round to 2 decimal places because that's what money is about. We know we've got rands and cents. So it doesn't make sense to write down 5 or 6 different decimal places when your money only works in 2. And they don't have to tell you that you have to round to 2 places. They expect you to have the sense to know that that is what happens. So now this becomes 1,020 and 10 cents. Now you can see it's slightly better than that, but it's not huge amounts. Now obviously if we carry on this process, things could change. So let's have a look at the 3rd year. In fact, let's be brave. Let's jump straight to the 5th year. And let's see how the 2 amounts are relating to each other at this stage. Right, the accumulated is 1,000. 1 plus 5 times 0,01. Close the bracket. Let's pull up our calculator again. So clear it. It's 1,000, open brackets, 1 plus 5 times 0.01. Close the bracket. And that's going to give me the answer 1050. So I think you can see here quite clearly that if we look here, it was 10 Rand more, 10 Rand more, 10, and it would keep on going. So 3rd year it will have 10 Rand more, 4th year 10 Rand more, 5th year another 10 Rand, making it 1,050 Rand. So as you can see, it's a constant rate of interest. Let's see what's happened to our compound interest. Well, if we have a look at the accumulated here, it's 1,000, 1 plus 0,01, all to the power 5. Let's pull up the calculator. So we have 1,000, open our brackets, 1 plus 0.01, close the brackets, raised to the power 5 equals. And you can see it's starting to improve. So now we've got, if you look at it, rounding it to 2 places, it's going to be 1,051 Rand, 1 cent. 1,000, I happily just left off my 50. And 1 cent. Okay, you still say to yourself, well, you know what, it's really not worth it. Let's just pull that calculator up and just check I copied that down correctly. No, I made a mistake there. It should have been and 1. So it should have been 1,050. 1. Right. So you can see it's improved a little bit. You're gaining 1 Rand and 1 cent. Now, if we carry this on indefinitely, and say we even went to our 100th year, we would see that there would be a huge difference in the 2 amounts. Because slowly what's happening in this case over here is we are getting interest on interest. So whatever extra you gain also gets interest. And so that makes for a much better situation. And in the long run, you score. So just remember, if you're ever saving money, a compound investment, and of course, the more often it is calculated, the more effective the difference is between the 2 amounts. Right, now as you can see, we've got interest on interest. And what I'm going to do, just one more of these, is I'm going to have a look what happens in the 15th year. Now, what do we anticipate at this stage? Now, one of the things that's very important with this section is that you're working with a calculator, and sometimes you can press the wrong button, as I'm sure you're aware by now. And so it's a good idea to have in the back of your mind an idea of how that answer should look. So if I'm looking at the 15th year, I have realized that every single time I've basically added 10 Rand to the amount. So I anticipate my answer to be 1,150 odd. So let's see if I've anticipated correctly. So the accumulated is 1,000, 1 plus 15, because that's the number of calculations, 0,01 being the interest. And let's pull the calculator up and see what we get. So we've got 1,000, open the brackets, 1 plus 15 times 0.01, close the brackets, equals, oh dear, and I think I have just pressed something wrong, so let's just go back up here. Let's take it up to the top. In fact, let's just clear it and put it in again. So we're going to go 1,000, open the brackets, 1 plus 15 times 0.01, close the brackets, and press equals. Yeah, there it is. And as you can see, it's exactly what I anticipated. So it's growing steadily by 10 Rand per year. Now let's go across to our compound interest and see how that formula has done. So it's 1,000 Rand, 1 plus I to the power of 15. Pull up our calculator again, and let's clear, and we have 1,000, open the brackets, 1 plus 0.01, close the brackets, raised to the power 15. Right, and that equals, and you can see it's 1160.968. Now remember what I said to you about us having to round to 2 decimal places automatically. Now if I'm going to round to 2 decimal places there, we know that the 968 means that the 8 will change the 6 to a 7. So it's 1160.97. 1160.97. And you can now start to see that that is a more substantial investment. All right, I must admit that this is not wonderful, but we are just taking a basic example, and we're only working with compounding yearly. Obviously, when you have a credit card, they compound daily. And of course, every day you owe the money, you end up getting more and more interest that you are owing. So it just depends, and you have to be very aware of it, and you often have to compare what the best investment would be or the best debt would be. So let's have a look now at another example, and let's see what it looks like. So let's go across to this. It says a bank offers 2 options. Option A is 14.5% per annum simple interest, and option B is 14% per annum compounded monthly. Now that is what's going to make the difference. Your gut feel is, if you look at that as, looks like the simple interest might be a better deal. So let's see if it is. You have 10,000 Rand to invest for 1 year. Which option will be best for you? Show you're working. So it's only 1 year. So again, you think to yourself, well, hang on a moment. When we looked earlier on, we saw that we could actually basically get much the same in 1 year. So really, the crux of this is, what difference does this monthly make to us? So right, let's have a look at option A. Option A, we've got simple interest. So our formula would be this one. All right. And our interest rate is going to be 0,145. Or if you want to, you can type in 14.5%. It's totally up to you. We know that our amount we're investing is 10,000 Rand. And we know that we're only doing it for 1 year. So in this calculation, with simple interest, only 1 year. N is 1. Right, so our accumulated would become 10,000 Rand, 1 plus our I, which is 0,145, times 1, close the brackets. Let's pull up the calculator and see what we've got. Right, so we have 10,000, open our brackets, 1 plus 0.145 times 1, close the brackets, equals. And we see we're going to end up with 11,450 Rand. So it's 11,450 Rand. All right, not bad. You've made quite a fair amount of interest. Let's see what happens now if we go the compound route. So option B, we're going to use the formula A equals P, 1 plus I to the power N. Now, what we're going to be careful of here, our interest rate is 14%, but it's being calculated monthly. Now what that means is they take the 14%, divide it by 12, and every end of the month they add on whatever that amount is. So if we think of it like that, let's take something simpler maybe. Let's say it was 12% compounded monthly. That means 1% per month. So what I would be saying to you in this case is if here we start the 1st of January, before the 1st of Feb, they will have calculated 1%. And then on the 1st of March, another 1%, and so on and so forth for the year. So you can see that this, by doing these calculations more often, we're more than likely to end up with a better answer. So let's go to the actual question. Right, how do we cope with our values here? Well, it's actually quite simple, really. What we do is we say, look, our I will be 0,14, because that's what they said. But I'm going to divide it by 12. Now, the good news is you don't have to actually work that number out first. Your calculator will do it all for you. All you have to do is write that down. Then, the number of calculations, well, that is going to change. Because instead of having one calculation like we did in simple interest, we are going to have 12. Remember I showed you that example with 12%, where every month you were getting 1%? Well, this time it's the same thing. So literally we're going to say it's 1 year, but it's going to be 12 calculations in that 1 year, which means N is 12. Of course, our amount invested hasn't changed at all. So going to our formula then, we've got 1 plus 0,14 over 12, all raised to the power 12. All right, let's see how our calculator does on this one. Right, so let's clear it. We've got 10,000, open a bracket, 1 plus. If we're lucky enough to have a calculator like this, we could even use this there. If not, we would just go 0,14, divide by 12, close the brackets, and that would be it. But we're lucky with this calculator, so let's put it in like this. Take it to the bottom of the fraction, put in a 12, spacebar out of it before you put your bracket, and then you're going to put it to the power 12. This now gives you that amount. Now you can see that if you're rounding to 2 places, it's not going to be so difficult because the 0 won't change the 2. So it's 11,493.42. 11,493.42. And I think you can see that that is a bit of a better investment. In 1 year you have gained 43 Rand 42 cents extra in interest. Now one can imagine if one left this for 5 or 6 years, how much better this option would be over this. So now all you would do to finish your question, because it said show your working, which option will be best for you, you've shown your working, and then you would conclude. Because remember, they actually asked you which option's best. So you would say option B is better, as you gain an extra 43 Rand 42 cents. Okay, so I think it's quite a nice little exercise, and it's actually interesting if you're ever thinking of investing at a bank to go around to a few banks, get a few interest rates, a few different options of investing. You know, it depends how long you leave your money in an account also, what interest rate they think. So if you've got a 24-day call, it's one interest rate. If you leave it there for 6 months or a month's recall, the interest rate gets better because then they can rely on that money being there for a bit longer. So you need to do the exercise. You need to think about for yourself whether you need this money urgently at any time or whether you can afford to leave it in a fixed deposit. But it's an interesting exercise worth going to do to see how this all works. Right, so now we have looked at that example. Let's see what's next. This says you have 12,500 Rand to invest, and your financial advisor suggests 2 options. Option 1, Saver Special, is 12% per annum interest compounded quarterly. Now, a very good skill when you're doing this kind of thing is to stress what's important. What I like to do is I go I, and I put a little bracket at the top here, 4, and I say is equal to 0,12. That reminds me that I'm going to divide that interest rate by 4, because if I'm calculating quarterly, that means 4 times in the year I'm going to work out that rate. So I need to find out a quarter and do a quarter every quarter of the year. Now this one says compounded monthly. So what I do is I go I12 is 0,11, and that just helps me to focus on it properly. Now, it's interesting because the thing they're going to ask you now is calculate the effective interest rate. So let's go and see how we're going to do that. There's a useful formula which is not given on your formula sheet, sadly, that goes as follows. It says 1 plus I effective equals 1 plus I nominal to the power n. Now let's just talk about this. Effective, what is the difference between effective and nominal? Basically, effective is what it means to your pocket. Nominal is what is quoted to you by the bank. So the bank might say to you, like they did up there, 12% compounded quarterly. But in actual fact, in your pocket, you want to know what the effect is in 1 year. So let's have a look at what would happen if we did this. Well, we would say 1 plus I effective, which is what I'm aiming for, is equal to 1 plus I nominal, which we said, I think, if I remember rightly, is 12%. Let's just go make sure before I start doing the question. Yeah, it was 12% compounded quarterly. So it's going to be 0,12. Remember, I talked to you about the fact that if it's 12%, you can use the 12% on your calculator, or you can use 0,12. I'm just prefer to work with a decimal. It's really a preference. I have to divide that by 4 because I'm compounding 4 times a year, but in 1 year I will have 4 calculations. So in other words, I effective is going to equal 1 plus 0,12 divided by 4 to the power 4 minus 1. Let's pull the calculator up and let's do this. Right, clear it. I'm going to rely on my memory because I can't really see what's going on here. So we're going to go 1 plus 0.12, divide by 4, get an answer. Raise it to the power 4, get an answer, and then subtract 1, get an answer. So you can see I'm going to get here 0,1255. So it's 0,1255. There's a whole lot of other places, but probably 4 is enough because most banks would not give you more than, say, 2 decimal places on your interest. Now, of course, remember I said to you that is equivalent to 12,55%. So the effective rate of this particular investment would be 12,55. That's what it would mean in your pocket at the end of the year. So let's see what the next one's about. Let's just go and put this in on the question so we can refer back to it at a later stage. So I'm saying it's 12,55%. Right, let's now go and do the same exercise, this time using my 11% compounded monthly. So it's going to be 1 plus I effective equals 1 plus. Now, of course, your rate is 11%, so it's 0,11. Divided by 12 raised to the power 12. Right, that means that I effective is equal to 1 plus 0,11 over 12 to the power 12 minus 1. Right, let's pull the calculator up and do that one. Let's clear it. It's going to be 1. In fact, this time I can actually see the question, so let's just put it like this. It's going to be 1 plus 0.11 divide by 12, close the brackets, raised to the power 12, space bar along, so we go to the bottom again, minus 1, and we're going to press equals. And we're going to see that we're going to get 11,57. So this is now going to be equal to 0,1157, which, as I've explained to you, is 11,57%. So you can see that the quarterly one is actually better than the monthly one. So we really anticipate that that's going to be the case. So let's see what else they ask us. So it's 11.57. Okay, just looking at that, clearly that would be the better option. Now, it says here, how much money would you accumulate if you invested your money in the Super Savers account for 10 years? Now, Super Savers is option 1. So that's where we're going to start working. So literally, I'm not going to use these effective rates. I'm still going to use this one. But I could have just as well used effective because it would make no difference. But let's keep to what we're going to do. So let's go back down here. We were going to invest 12,500. So let's just take it down. Let's clear this off so we've got some space to work. And let's start. So right, we are going to invest using compound interest 12,500 Rand. Our interest rate was 12% compounded quarterly, and that means that we're investing for 10 years, so each year is going to have 4 calculations, which means our N is 40. Now, there's nothing wrong with actually putting those kind of substitutions on the actual formula. So what I'm saying is you could have gone straight here and said accumulated equals 12,500, 1 plus 0,12 divided by 4, and this is going to be 10 times 4. Okay, but if you do it this way, you could also have said, well, I know that if I divide that in there, I'm going to get 0,03, and you could have gone to 12,500, 1 plus 0,03, all to the power 40. But quite honestly, with the calculators we've got, we actually can go there with ease. So let's go there and see what we're going to get. Okay, so 12,500, open our brackets, 1 plus 0.12, divide by 4, close my brackets, raise to the power, and if you wanted to, you could even go 10 times 4 if you wanted to. All right, press equals, and there we have our amount. We have 40,775 Rand, 47 cents. So 40775 and 40 cents. So that's how much money I accumulate if I use the Super Saver option. So it's 40,775 and 40 cents. Right, now the next question gets a bit interesting. It says, how much longer would you have had to invest your money in the real returns account to accumulate the same amount as investing in the Saver Special for 10 years? Give your answer to the nearest month. Now, interestingly enough, this is actually grade 12 work. I'm going to set the equation up, but in our next lesson, when we actually deal with the grade 12, I will do similar examples and show you how we go about solving it. But for now, all I'm going to do is quickly just show you how we would get this set up. All right, let's get some space. Right, so what do we know? We know we're still using the same formula as before. But this time, our interest rate is 0,11 divided by 12. The number of years is going to be 10 times 12. And this time, no, sorry, I'm wrong. It's not the number of years. We're actually trying to find that. So we're looking for that. So whatever n is, we're going to say 12n because it's 12 calculations per year. Or I suppose we could work out, well, let's go with that route first of all, and then we'll see what happens. Right, now we know that our principal amount was 12,500, and our accumulated amount was 40,775.40. Right, so if we go over here, 40,775 Rand and 40 cents must equal 12,500, 1 plus I, which is 0,11 over 12. And just so we've got some space here, let's just take this away. We know that we're going to do it to so many years, but every year is going to have 12 calculations. Now, you can see that the problem here is we've got a power. Let's just tidy it up a little bit so you can see why our matric work becomes important. So it's 40,775.40. And obviously to lose this, we need to divide by 12,500. And that's equal to this here. Now, if we do this on the calculator, just that part, we are going to get 1 plus 0.11 divided by 12 And we're going to get that answer, which as a decimal is 1,00916667. But just for the purposes of this, I'm going to go 1,009 to the power 12n. In an exam, if you write down part of it, that's fine. But make sure your calculator carries the whole display, because it's amazing what those little decimal places can do to your overall answer. So please remember, don't clear your calculator if you're midway through a question. You'll see when I start working on some of the harder ones from grade 11 what I mean. Now you can see at this moment in time, we could also work this out. But you agree with me, to solve something like this at the moment in grade 11, we would have to know that we could get the bases the same and equate the exponents, because that's how we do it. So in other words, if I had something like this, you would know to go 2 to the x equals 2 to the 4, and therefore x is 4. Now this is not possible at this stage, and that's where your grade 12 work comes in, because we need to use a section called logs, or logarithms to use the proper name for it. So at this stage I'm going to leave it here as a probable question to be done very shortly and to be solved. So you can see that what they could do in an exam, this is an exam question, they can start it off very gradually using some grade 11 work and then spin it into grade 12, which is what this is. So it's actually an interesting way of looking at it and seeing how this works. Right, so I'm going to leave it there. Don't worry, when we get to the finance in grade 12, I will show you exactly how to solve this. Right, let's go and have a look at the next one. Here it says there's a special investment opportunity, has someone investing 8,000 Rand at 10.25% per annum for 4 years. Interest compounded quarterly, and then it is changed to 10.5% per annum interest compounded monthly. A friend ignores this offer and invests his 7,500 Rand at 10.6% per annum interest compounded monthly. So now it says calculate the first person's amount after 10 years. So this is the original guy, and this is the one here who has ignored the advice. So let's have a look what happens. I personally think it's a good idea to draw a timeline. So T0 is when we come along with our investment and we put in our 8,000 Rand. Now we know for the first 4 years, one lot of interest is happening, and the interest rate is 10.25%, and it's compounded quarterly. So remember how I did it? I put R with a 4 in a bracket like this, equals, and then it says at this point things change, and for the next few years the interest rate is now going to be compounded monthly at 10.5%. So things are going to change and become a little bit better on this investment. So let's see how this guy does. Okay, so let's start. We know that he's going to accumulate. Now what I find works quite well is to think to myself how it's moving along this particular timeline. Now one way to do it is to work it out to this point, put an answer down, and then start a fresh calculation getting that. So what I will do is I'll do it both ways, and then you can decide for yourself what you like. But personally, I think it's worth growing this investment right to the end. So what am I doing? I'm taking 8,000 Rand and I'm investing it at this interest rate, which is 0.1025, calculated quarterly, which means divide by 4, for 4 years. Now, if it's 4 years and there are 4 calculations per year, that means there are going to be 16 calculations at that interest rate. Right, now at this stage, interest rates change. So this is now represents my new amount at this point. And so I'm going to say, right, this now gets 1 plus 0.105 divided by 12. And this is going to get 12 calculations per year for 6 years. So 6 12s are 72. So this enables me now to work out that total investment for this particular person. So let's bring the calculator up and let's put it in. So it's 8,000. Open the brackets, 1 plus point, I'm just going to move it ever so slightly up, 1025 divide by 4, close the brackets, raise to the power 16. Now space bar down because you don't want it to be up on the exponent. Open the brackets, 1 plus 0.105 divided by 12, close the brackets, raise to the power 72. Okay, and then that equals that amount. So I'm going to end up with 22,455 Rand, and rounding off it'll be 51 cents. So it's 22,455, and I think it was 51 cents. I'll just check again. Yes, it was. Perfect. Right, so that's how much money will end up at the end of 10 years in this particular case. So that's worth knowing because later on we're going to do a comparison of the two. Right, so I'm just going to show you the other way to do this so that you can choose for yourself what you find easier to do. The other way of doing it is we start again, literally, so take that all away. Okay, now what we're doing is we're saying, okay, we're going to work to this point. So let's take I almost do this to it. I say A4 because I'm saying accumulated at year 4 equals the amount which was 8,000 Rand, and it was 1 plus 0,1025 divide by 4 all to the power 16. Right, so pull the calculator up. And literally, we type this in, so it's 8,000, open the brackets, 1 plus 0.10, was it 55? Let me just check, 25, nearly made a mistake, it's a good thing I checked. 1025 divided by 4, close the brackets, raised to the power 16. Right, so that gives me this amount, which is 11992 and 44 cents. 1192 and 44 cents, I think. Let's just check it again. Yes, perfect. Now, at this stage, what I have to do is I have to say, right, this is my new amount, 11992 and 44 cents, and I start a fresh calculation to the end there. So what I'm going to do now is I'm going to say accumulated at 10 is 11992 and 44 cents. 1 plus 0,105 divide by 12, and again it's 6 years times 12, so it's still to the power 72. Okay, I'm rather squeezing this in here, so let me write it a little bit more closely. So it's 11992 and 44 cents. 1 plus 0,105 over 12 to the power 72, and let's erase this other one because it is a little bit on the tight side there. Right, so out with a calculator. Let's bring up the calculator again. Now notice I have kept that answer in the actual calculator. I will not clear it because that little bit of extra decimal places makes a difference to your answer. So I'm going to say that times, you notice how the calculator shoots up the answer immediately. And in brackets, I'm going to go 1 plus 0.105 divide by 12, close the brackets, all to the power 72, and I'm going to get equals, and you can see I get exactly the same answer I got before. If you compare that to the answer sitting over here, you will see that that is absolutely identical. So A10 is 22455 and 51 cents. Right, so now, in actual fact, you can decide which one you prefer. I will use this method and the other method, just so you can see them and compare for yourself and decide what you are more comfortable with. Right, now the next question says, whose choice was better? Well, we know how person A has done. We have no idea how person B has done, so that's what we're going to sort out now. So what is the difference in these two people? He's taking 7,500 Rand. He's investing it at compounded monthly rate of 10.6%. He's still doing his 10 years just like this first person. Okay, so let's have a look what happens with him. Now, here we don't need a number line or timeline as we call it, because in actual fact this is a straight calculation. We're not changing anything, we're not altering anything, it's a straight money in for 10 years at a fixed interest rate, and that's it. So it's going to be 7,500, 1 plus 0,106 divided by 12. And of course 10 years at 12 calculations a year is going to be 120. Right, so now we're ready to pull up the calculator and see what this guy actually makes. So all clear, so we've got 7,500, open the brackets, it was 1 plus 0.106 divided by 12, close the brackets, raise to the power 120, and if I press equals, that's what he ends up with. So your immediate reaction is, oh well, definitely person B didn't do so well. Well, we have to actually still go a little further than that because it's not so easy to compare these. So the amount is 21547.26. So 21547 and 26 cents. Okay. Right, so in the light of that, let's just make sure I've written down the right value so we can carry on from here. 2154.26, yes, that's correct. Right, let's have a look now at this. So this is person B's accumulated amount, which is lower than person A's, I give you that. But however, to see who had the better value over the years, we need to do a little bit more. So what we're going to do is we're going to go back to this guy here, and we're going to say, what did he invest? Well, person A invested 8,000 Rand. He ended up with 22,455 Rand 51 cents. Person B invested 7,500 and has ended up with 21,547 Rand 26 cents. Right, so now we ask ourselves, how do we compare these? Because they invested different amounts. The thing that was the same is how long they invested it for. So one of the things we could do is we could look at the percentage increase that they made on their original investment. What do I mean by that? Well, what I do is I take this amount, this 22455.51, I subtract the original investment, and then what I do with that is I then work out a percentage. So I'll take this answer, divide by the original amount, times 100 over 1, making it a percentage. So let's pull the calculator up and see how he did. So we're going to say 22455.51 minus 8,000. We're going to divide that by 8,000. And we're going to times it by 100. And we're going to find that he made 180.7, if you like. So 180.7%. So he made back his original plus 80% more of the money he invested. So that's pretty good. Let's see how this person B did. Let's pull up the calculator. Well, first of all, before we pull up the calculator, let's set up the equation. I think I'll do him in black so it's more clear. So we're going to take 21547.26 and we're going to subtract 7,500 and we're going to divide it by the original investment, 7,500. Let's pull up the calculator. So all clear. We're going to go, and remember we're going to times it by 100 over 1. So we're going to go 21547.26, subtract 7,500, divide by the original investment, times 100 over 1. And I'm going to find that he made 187, and I didn't look quickly enough there, 0.3. And so in actual fact, the second person actually did better than the first person. Not what you would expect, but you see how we have to bring it to the same thing in order to compare. It was no good just looking at what money they had in their bank because they'd invested different amounts of money. Right, so that's a little bit more of a tricky question, something more for you to understand, but I'm sure you've done examples like this before. So let's move on to the next one. Right, now what I'm going to do for a few seconds is talk about depreciation. Now, depreciation is unfortunately a horrible fact of life. Everything anything that you buy, your car, I don't know, anything, computers, whatever, they will always depreciate in value over time. We have got two kinds of depreciation. The first one is what we call straight line, and the other one is reducing balance. Now, if we're talking about straight line, the formula is in fact simple interest. So it's going to be the accumulated is the principal, 1 minus, notice I'm taking off the interest now, IN. This is on your formula sheet. While we're talking about formula sheets, I'd like to spend a few seconds just talking to you about a formula sheet. They are useful things. But my advice to you is rather don't rely on them completely. Rather make a point of knowing your formulas and keeping your formula sheet in case you should forget one. Because this is what makes the difference in time. Time issues become quite important, especially if you're going for a really good mark. So you don't want to waste time having to hunt on your formula sheet for a particular formula. Right, now the reducing balance one is compound interest. Notice once again, we now subtract and raise to a power. So it's exactly like the previous formula, but this time we have subtract signs instead of add signs. Because obviously if something's appreciating or inflating, we might use that word, we would add, but if it's depreciating, it's going down in value, and so we use the negatives. Right, what do we know about these two? Obviously, we saw with the saving that it was better sometimes to, well, most times, to go with the compound interest version rather than the simple interest. However, here too, the same happens. Because with straight line depreciation, your object can be worth nothing. With reducing balance, there will always be some value. Now, cars are definitely worked on the reducing balance. As you drive your car off the showroom floor, it depreciates. And the biggest depreciation is usually in your first year because the car is worth more. And so if you're taking a percentage of that, you're going to take a bigger amount off than in the second year, in the third year, in the fourth year, etc. So this way, we still have some value. This one, we don't have so much value. So let's just take a simple thing. Let's take, let's say we've got computer equipment worth 8,000 Rand. And let's say it's depreciating at, I don't know, let's make it 16%. And let's say we are going to do this over, let's make it 5 years. So we're going to sell our stuff off at 5 years, and we're going to see how we're looking. So if we're going with the straight line version, we're going to say the accumulated is 8,000 Rand, 1 minus, now remember we talked about this, you can do this, or you can write what I prefer to write, that. So it's 0.16 times the 5 years, and let's see how we do on the calculator. Right, so let's clear it. It's 8,000. Open the brackets. 1 minus 0.16 times 5. Close the brackets. And we want to get the answer of that, which means it's worth 1600. So you can see that your thing has got hardly any value. Now, if we went a bit further, eventually this would become 0. But let's see what happens now on the reducing balance. Using exactly the same information, let's see how that differs. As you can see today, we really are using our calculator. And you can see your computer equipment is worth much more, 3,345 Rand, 70 cents. So 3,345, 70 cents. So obviously that's the better idea for depreciation. So we can be grateful that our cars depreciate on a reducing balance. Now what I'm trying to warn you with by doing this is saying to you that you must look at your question and you must see what kind of depreciation it is. If they say straight line, you have to use the formula for simple interest. And if they say reducing balance, you must use the formula for compound. To be honest with you, most things are working on reducing balance. Right, let's move across now to an example and let's see how it goes. It says a company buys computers that cost 325,000 Rand. The computers depreciate at a rate of 18.5% per annum, calculated semi-annually. Watch that. That's something you have to be aware of, because compound, remember, you can have more than one calculation in a year. On a reducing balance basis, which means we are working with a compound interest version. Determine the value of the computers at the end of the third year. All right, so we're working with our reducing balance, which is this formula. Our value at the moment is 325,000. Our interest rate is 0.185, but it's calculated semi-annually. What does semi-annually mean? Semi-annually means twice in a year. So it'll be in the June and in the December. So we need to divide that by 2. And then it's for 3 years. So it's 3 years, but it's calculated twice a year. So we're going to get that. Right, so now we're ready to put our formula together. So our accumulated equals 325,000, 1 minus 0.185, divide by 2, all to the power 6. Right, while we're here, let's just talk for 2 seconds about what is given marks. Obviously, writing this formula down is not the marks, because you get given that on your formula sheet, so it's considered given and not requiring any allocation of marks. The marks come in when we start doing the actual substitution into the formula. So I personally would have ascribed a mark for that, because you knew you had to divide by 2, and a mark for that. Let's carry on with the question and see what happens. So that's equal to, let's pull the calculator up. Okay, let's clear it. It's 325,123. Open your brackets. It's going to be 1 minus 0.185, divide by 2. Close my brackets, raise to the power 6. I'm going to press equals, and you can see that is what my computers are now worth. So it's 181,536. So 181,536. And just let's finish the rest of that number. It's going to be 17 cents. And that would be, for me, the final answer. So say that question was worth 4 marks, that would give me what it is. And you can see it's devaluated, well, nearly half of its value. But that's fine, at least it has some value. And as we've been doing straight line, we might have been looking at a very different situation. Right, let's see what the next example is. This one says you purchase a car for 100,000 and the depreciation rate will be 13% per annum. So this is a per annum. On a reducing balance, so we're still working compound. Now they bring in another word. They bring in the word inflation. Inflation is expected to be 8% per annum for the next 5 years. Now it says, in what year will your car lose the greatest value? Now, clearly, that is going to be the first year, because every year you're reducing it. So in the first year, you reduce this amount by 13%. In the next year, you reduce the new amount by 13%, but the new amount will be less. So this one's easy. You can straight away go and say first year. It's only worth 1 mark, so I'm sure that's more than adequate to just have a knowledge of it. I don't know if you know, but in your exam papers, we always set questions knowledge, routine, complex, and problem solving. This would be considered knowledge. I will refer to that every now and then just to remind you how you need to think about your questions. Now it says, what will the value of your car be after 5 years? So now it looks like we have to depreciate it at that 13% per annum on a reducing balance. So for B, let's have a look. We are going to use A equals P, 1 minus I to the power N. And we know we are doing 13%. So it's going to be 1 minus 0.13. And it's after 5 years. And the value of the car was originally 100,000. Right, so now looking at that, let's pull our calculator up. So we've got 100,000. I'm missing a naught, I think. Yes, that's right. Open the brackets. 1 minus 0.13, close the brackets, raised to the power of 5 equals. And we see the car is worth only 49,842 Rand and 9 cents. Right, so now let's write down this value. It is 49842. So 49842. And now we need to get hold of the rest of the number. So let's just check it again. And it's 9 cents. Great. So you can see your car has lost a lot of value, but it still has value. So it's 49842 and 9 cents. Now, the next question says to me, what would the cost of a new car be in 5 years' time? So now they're referring to the inflation. So let's go up to the question again and remind ourselves, inflation is expected to be 8% per annum for the next 5 years. So now what I've got to do is see what it would cost me to go and buy that same car 5 years later, assuming that's how the prices are going up. Right, let's have a look at it. Right, C, we have got accumulator, but now of course what we're doing is we're adding value to the car. So we're going back to our formula for appreciation or inflation. And we're going to say this is 100,000. 1 plus 0,08, and it's for 5 years. Right, let's pull the calculator up again. This calculator is definitely working overtime today. So it's 100,000, open the brackets, 1 plus 0.08, close the brackets, raised to the power 5. Right, that will give me that. So now to buy exactly the same car, equivalent car to what I had 5 years ago, it's going to cost me 146,932 Rand and 81 cents. So let's write that down, 146,932, and let's just pull that calculator up to get the rest of the number, and 81. You can see that we're going to have a huge problem here, what your car is worth to what you have to now pay for exactly the same car. Right, now it says, if you used your old car as a trade-in in 5 years' time, how much more money will you need for a similar new car? Well, that's going to be relatively straightforward. What they're asking me to do in D is to say, let's take this 146,932 and 81 cents and subtract from it what I will get as a trade-in value on my car. Sadly, this is very realistic. So those of you that are planning on a car, just know that it's very hard once your car has depreciated to that value to actually get a new car of an equivalent status. Obviously, you can go and buy a nice, good second-hand car and all will be well. So let's get the calculator up again. I've still got that figure in there, so all I have to do is subtract. Notice immediately it throws the answer up there, 49842 and 9 cents. Right, that means I need 97090, 97090, and pulling it up again, 72 cents. Okay, so that's how much more money I would need to find in order to buy myself a car of the same standard. Quite scary, really, when you realize how much depreciation and inflation affect your daily living. And this is why I'm quite excited about finance being in your syllabus, because it gives you a real application, something that you can use every day to live. Let's move on to the next example. Right, let's look at the next question, and I'm going to concentrate a little bit on timelines now so that you can get a better understanding of them. Now, I've already told you it's a timeline, so I'm going to put a timeline out here. Let's have a look why I make that decision. It says Fred takes out a loan of 350,000 Rand in order to start his business. So what I would do is I'd immediately go T0, and I would say he's taking out a loan of 350,000. He repays 150,000 2 years later. So T1, T2, he repays, so notice how I'm showing my arrows, he takes out, he repays 150,000. 4 years after taking out the loan, he borrows a further 560,000. Now here we must be a little bit careful, because it's not saying 4 years from here, it's saying 4 years after taking out the loan, so it's 4 years from here. So that's where he's going to take out some more money, and he's borrowing another 560,000. He pays off his total debt by means of a payment of X rand 3 years later. So 3 years later from here, T5, T6, T7. So this is where he repays with X. The interest rate is 18% compounded monthly. So I12 is 0,18, or you could write 18, whatever percent. Calculate X. So they want to know, what does he owe here? That's all they're asking, really. So what we're going to do is we're going to look at the timeline, and we're going to try and work out exactly what that is. Now remember, I said to you there are two ways to handle this. The one way is to work to all the problem points. And once you work to the problem point, the end product, or you take the whole thing to the end and get it. So I'm going to take it to the whole thing to the end rather, and then we can see if we prefer to go the other route. Right, so what are we going to do? We're going to say the accumulated amount owing is going to be 350,000 Rand. Now what is happening to this 350,000? It is owing for 7 years. We just say, but hang on a moment, Lee. This here is being paid in. Yes, it is being paid in, but what I'm doing is I'm looking at this amount to the end, this amount to the end, and this amount to the end. Now you'll see when I do the other method how it works, and you can decide which one you prefer. So what am I going to do? I'm going to say it's 1 plus 0,18 to the power, divide by 12, because we're calculating monthly, to the power, there's 7 years, and 7 12s are 84. Right, now they said to me, I pay back 150,000. So from that amount, I must subtract 150,000. And in effect, by paying that back, I will have gained the interest back that I lost there. Right, so it's 1 plus 0,18 divided by 12. And this amount is from the 2nd year to the 7th year, so it's 5 years. 5 12s are 60. Right, now I borrow again 560,000. Okay, and if I borrow that 560,000, that must now get interest for those years, which are 3 years. So it's 1 plus 0,18 over 12, and it's 3 years at 12 calculations a time, so it's 36. Now I'm saying to you that that will provide me with the answer exactly correct in one shot. So let's pull the calculator up, and let's have a look at that. I'm going to bring this calculation higher, so when I pull the calculator up, we can still see most of it. Right, so we clear the calculator from the previous question. 350,000. It's going to be 1 plus 0.18, divide by 12, close the bracket, raised to the power 84. Now I'm going to press equals, because what happens if you don't do that, sometimes your display gets too full when there's too much going on. And if it gets too full, then you can't input all of it. It'll actually probably swear at you and say, don't do this. So I'm going to actually do that, and then rather, as I get each part, I'm going to press the equal sign to make it a shorter display. So from that, I subtract 150,000, and that's also getting the interest. So it's 1 plus 0.18 divided by 12, and this one has been raised to the power 60. Now, personally, I think at this stage I could actually probably finish up the question just inputting, but just because I said I was going to do it, I'm going to press the equals again, and then I'm going to add to that the amount he borrows here, so 560,000, open the brackets, 1 plus 0.18, divide by 12, close the brackets, raised to the power 36. And that's what I find he still owes. So after all this time, he owes basically 1,813,041 rand and 51 cents. Now I'm sure this is going to take a few chances for me to actually write this out without losing it. So I'm going to do bit by bit. So it is 1813. Let's pull up the calculator again. 04151. 04151. So that's how much he will owe at the end of that time. Quite a lot of money. I'm sure you realize that that would be a huge amount to actually meet at the end of that time. Right, let's go to the second way to do it. Right, the second way to do it is I basically do this bit by bit. So I start off by saying, let's take this 350,000 that he's owing and work it from here to there. Once I'm at T2, then I would subtract what he pays and I'd go and work it out. So what I want to do is quickly just store this number so we can compare it at the end. 1813041 and 51 cents. Right, let's take this away now. And let's go back to the question and work with it. So what I'm going to do now is I'm going to say accumulated at 2 would be 350,000, 1 plus 0,18 divided by 12, and that is going to be for 2 years, 12 calculations per year, so it's going to be 24 calculations. Right, let's pull up the calculator. So it's 350, open the brackets, 1 plus 0.18, divide by 12, close the brackets, raised to the power 24 equals. And you can see that is how much money he now owes after 2 years. Also a scary amount. So it's 500,325, and let's just check the rest of the number. 98 cents. Right, now I'm not going to clear the calculator at this stage because I'm saying to myself, at that stage, that is what he got, and I must subtract from that 150,000 because that's what he's putting in as payment towards his debt. So pulling up my calculator again, I would now say minus 150,123, right, equals. So now you can see what he owes is 350,325 and 98 cents. So this now becomes my new amount at this point. Now everything goes well again till I get to the 4th year. So what I would do now is I'd say, right, at A4, I'm going to take this 350,325, 98, and I'm going to add on interest at 18% calculated monthly, and again it's for 2 years, so it's 24 calculations. Now you can see that this is a very logical way to do it. It actually makes it easy for you to understand. But it's also quite clumsy, and it lends itself to making errors because you often are writing down numbers off the calculator. Right, let's pull it up and let's carry on the question. Notice I've still got my figure in the calculator. I did not take it away. So what I'm going to do now is I'm going to say times, open the bracket, 1 plus 0.18, divide by 12, close the brackets, raise to the power 24, and we're going to get that answer. So we can see at this stage, this is what he owes. So let's write it in 500,791, and let's just put it up for the cents. Notice in the actual work, I'm writing in 2 decimal places because that's what they expect from me. So it's 98 cents. But he's going to borrow a further 560,000. So at this point, I add on 560,000, which, as you can see, makes this amount of money quite a lot. So we add on 560, 1, 2, 3, right, equals. So now we see that he now owes, sorry, I didn't write the number down, 1060, 791.98. So now this gives me this new amount. Now, unfortunately, I still have to grow this debt to the end here. So now it's going to grow another 3 years like that. So to get to A7, I'm going to go 1060791.98. I'm going to increase my interest like I did before, but this time it's 1 to 3 years, so 3 12s are 36. Unfortunately for me, I've still got that information in the calculator. So let's pull that up. No, I think I'll leave it down there actually. Let's go to the calculator. There it is. And so I have to times that by, open the brackets, 1 plus 0.18, divide by 12, close the brackets, raised to the power 36. That's going to give me that amount, which as you can see is absolutely identical to that. So really what I'm saying to you here, this comes down to a personal preference of how you are less likely to make mistakes. So what I'm going to suggest is that you try these methods out, try to work it to the end and see if it works for you. And if it doesn't work for you, then go with this idea where you're working out every time there's a problem area. I'm going to do one more example like this with you, where I show you that sometimes working out every time there's a problem area can become extremely problematic. So let's move to the next question. Right, the next question talks about Lebor, wants to buy a car in 3 years' time. The car she wants is currently costing 65,000. She invests 10,000 Rand now in a bank account. So the cost of the car at the moment is 65,000 and she's investing 10,000. In a year, she plans to deposit another 10,000 into the account and a further 6 months another 15,000 Rand. So she's going to be saving up a storm. The interest rate she will earn on the investment is 12% per annum compounded quarterly now. After 2 years, the interest rate will be 14.5% per annum compounded monthly. In 3 years from now, her father will give her the difference between what the car costs and the money that she has saved. Nice, Dad. So let's have a look at this and see how we can do it. The first thing says, what is the price of the car 3 years' time from now if the inflation, so we're adding on interest, is 7.5 per year. So we need to work out, although the car is worth 65,000 at this moment in time, we need to work out what it'll be worth when she actually has finished saving her money. So we're going to go to accumulated equals principal, 1 plus I to the power n. We know that it's 65,000, 1 plus 0,075, and it's for 3 years, so we're looking at that. So right, let's pull up the calculator. 65123. Okay, open the brackets. 1 plus 0.075, close the brackets, raised to the power 3. And we find her car is now costing 80,749 Rand 30 cents. So 80749 and 30 cents. Let's just check I wrote that number down correctly. 80749 and 30 cents. Perfect. Right, so now we know this is her goal. Her goal is to have this much money in order to buy her car. So I'm going to put it over there and I'm going to take that out. All right, so now what do we need to do? We need to now set up some kind of number line so we can see what's going on with her savings. So here we go with our timeline. Let's go down here, and I'm going to have to refer up and down. I've brought some of it down here. Right, we're talking about T0, and we're saying she is going to put in 10,000 Rand. At T1, she's going to put in another 10,000 Rand. So there it's going into the account. And then 6 months later, they said, and I'm sure that is what it said, let's just make sure. Okay, it says in a year she plans to deposit another 10,000 into the account, and a further 6 months, another 15,000. So I am right. So in goes 15,000 Rand. All right, now, unfortunately for us, the interest rate's doing wonderful things as well. So let's go back and see what that's doing. It says the interest rate she will earn on the investment is 12% per annum compounded quarterly now. After 2 years, the interest rate will be, so at 2 years, it's actually going to change around. So let's go down here, and we say for this part here, she's earning, was it 12%? Yes, 12% compounded quarterly. So remember how I do it? I go I4 is 12%. Right, now we know she's going to 3 years because after that her father is going to save her. So at this stage, we're going to go down here and we're going to say in 3 years' time, the interest rate was 14,5 compounded monthly. So it is, whoops, too far. Let's bring it down a bit. 14,5% compounded monthly. All right, for the rest of the time. All right, now it says calculate the balance of the bank account after 3 years. So after 3 years, we're going to do this. I'm going to do it all in one shot, first of all. And then if we have time, I'll show you the other method. But you can see that if we were doing the other method, it would be problematic. We'd have to work from here to here, get an answer. From here, oops, I've just realized I put in something incorrectly here because it said that after further 6 months. So it's actually here that she put in her 15,000 Rand. Okay, so just be careful with your number line. Just remember that that's a T1.5. All right, so now what we're going to do here is we're going to work out this balance, and I'm going to work it, and you can see we would have had to work out here, work out here, work out here, and then work out here if we did the long method, which would have been hideous. Okay, so let's have a look what we've got. We've got 10,000 Rand going in, and we know that that's going to get for 2 years an interest rate of 12% compounded quarterly. So 2 years, 2 times 4 is 8. That's where we're getting that from. And then it's going to get this interest rate, divide by 12 for 1 year, so it's going to get 12 lots of interest. So that takes care of that very first amount. So what I'm going to do is ring it so you can see which one I'm working with. Let's go to the next one now, and let's ring this one. What's happening with this amount? Well, I'm going to add on 10,000 Rand. This time it's only getting 1 year at the first interest rate. So it's 1 year times 4, and it's going to get this for 1 year times 12. Right, then we're going to go to the next one, which is this one. And then to that I'm going to add 15,000 Rand. This is only going to get half a year. So it's 1 plus 0,1204. And if I say a half times 4, it's going to be 2. That's logical because if it's only half a year, it's only 2 calculations, if they're 4 per year. 1 plus 0,145 over 12 to the power 12. Now all I'm going to do is I'm going to put that in the calculator and work it out. When we mark this kind of thing, we mark a lot in here. So we would say, okay, you knew this, you knew that, you knew this, you knew that, you knew that, you knew that, you knew that, and you knew that. So pretty much you're looking at about 7 marks for just doing the basic step, and then the final mark would be your calculator work. So let's organize the calculator, but before we do that, let me change back to the black pen. Okay, let's bring it down because I want to keep the thing I'm inputting down there so I can see it. Let's pull this up. And let's start calculating. So let's clear. We've got 10,000. We are going to go 1 plus 0.12, divide by 4, close the brackets, raise to the power, I think it was 8. Just covered over a little bit there. And then I space bar down and I go again brackets, 1 plus 0.145, divide by 12, close the brackets, raise to the power 12. And I'm going to press equals because you can see that we're going to get quite a long solution here. Right, to that I'm going to add 10,000, open brackets, 1 plus 0.12, divide by 4, close the brackets, and now it's to the power 4. And I'm going to times that again by 1 plus 0.145, divide by 12, close the brackets, raise to the power 12. And I'm going to hit equals again, so now you can see what we're looking at. And to that, I'm going to add the 15,000. 1 plus 0.12 divided by 4 raised to the power 2 times by 1 plus 0.145 divided by 12, close the brackets, raised to the power 12, and I think that's it. And that's what I end up with. So we end up with her having 46,012 Rand. I'll bring this up a little bit in a moment, and 32 cents. 32 cents. All right, wonderful. So we can see that's how much she's got in her savings account. She hasn't done badly, but it's not going to be enough for her car. Now the last question says, calculate how much Lebo must receive from her father in order to buy her car. Well, what we're going to do is we're going to go up here. We're going to see what the car is costing her, which is 8749. And the cents is 30 cents. That's how much the car costs. From that, I'm going to subtract her savings. And her savings are 46012.32. And I'm ready to actually find out how much her father is going to help her out. And I do think she's got a very generous dad. So let's get hold of it. So that's the amount she had there. So what I'm going to do is I'm going to go 80749.30. And I'm going to subtract the answer, giving me that. So it's 34736, 34736. And pulling up the cents, it's going to be 98 cents. So her dad is going to help her with 34,736 Rand, 98 cents. Lovely. So you can see that this section is very, very useful. And I hope you've enjoyed going through some of your old work. Thanks.